our understanding of the universe is not as advanced as we might think. The space telescope we've created has captured remarkable images of the cosmos, and it turns out that its power is so immense it could potentially challenge our perception of the universe's history. Before the Big Bang, the cosmos underwent an extraordinary expansion at a speed up to 80 times faster than the speed of light in a fraction of a second, causing an immense inflation. This rapid growth transformed the universe into a cold, empty void, halting its expansion and converting vacuum energy into matter and radiation, marking the onset of the Big Bang era. During this period of extreme heat and density, the fundamental building blocks of the galaxies and stars that we observe today were formed. The James Webb Space Telescope has explored the distant past, unearthing unexpected discoveries that challenge our comprehension of the cosmos, particularly what existed before the Big Bang. This revelation has startled the scientific community and raised profound questions about the nature of the universe before the Big Bang. Prior to the Big Bang, the universe did not exist in any form and was created during an event that occurred approximately 13.82 billion years ago. These galaxies we observe today were originally part of isolated islands of stars within the vast universe. Despite initial skepticism from some scientists, the evidence of this sudden creation is undeniable, evidenced by galaxies moving away from each other like cosmic projectiles, and the faint afterglow of the Big Bang still detectable as microwave radiation, known as the cosmic background. In 1965, the concept of the Big Bang was proposed, but not as a singular event that took place at one point. Instead, it suggested that the universe expanded and emerged simultaneously in every direction. This event did not take place in an existing vacuum, but rather space-time itself emerged along with the universe's expansion. A popular analogy is to picture the universe as an expanding cake, where galaxies, represented by raisins, move apart with no specific central point of origin. However, unlike a pie with a definite boundary, the infinite universe is boundless and eternal. During the inflationary period, the vacuum was filled with energy, which increased in proportion to its volume, like a stack of bills that grows exponentially with each doubling. This inflationary energy dissipated in a random manner, giving rise to matter and the heat associated with the Big Bang. This enormous vacuum, which could be considered infinite, gave rise to our current Big Bang universe, which is one of countless bubble universes. This process began with a small amount of inflating vacuum, and quantum theory suggests that such phenomena can seemingly emerge from nothing. While the Big Bang theory presents certain limitations, it remains a solid hypothesis. It is generally accepted that the universe began in a hot, dense state and has been expanding and cooling ever since. However, uncertainties still surround the finer details of how this expansion fits with various observations and how the universe itself originated. To account for these observations, cosmologists have had to refine the initial Big Bang model. According to this theory, the expansion of galaxies is attributed to the gravitational pull of matter. But if gravity were the only factor at play, galaxies would have taken much longer to form than the estimated 13.82 billion years. Interestingly, though, in 1998, astronomers discovered that the expansion of the universe is actually accelerating. This acceleration is thought to be caused by dark energy, an invisible form of energy that fills space and has a repulsive gravitational effect. Additionally, the constant temperature of the universe presents another challenge to the Big Bang theory. Some astronomers suggest that the universe might have initially been much smaller than previously expected, followed by a rapid and immense expansion in the very first moments of its existence, an event known as inflation, triggered by an energetic form of vacuum that already existed in space. The James Webb Space Telescope has captured breathtaking images from a distant corner of the universe, revealing information previously unknown to us. Launched on Christmas Day 2021, the telescope aims to detect light from the earliest stars and galaxies, helping us understand the earliest moments of the universe. It is considered the successor to the Hubble Space Telescope, boasting a capacity 10 billion times more powerful. Since its launch, the James Webb Telescope has captured incredible images of galaxies that formed only a few 100 million years after the Big Bang, as well as images of the moments right before new stars were born. The telescope has also captured the first direct image of an exoplanet and photographed the Tarantula Nebula, a region rich in young stars that were previously invisible to the naked eye. Moreover, the telescope has unveiled new hidden structures and intricate details of vast gas clouds like the pillars of creation. Recently, an image of NGC 346, located in the Small Magellanic Cloud, was published. This galaxy, about 200,000 light-years away, is already known as a stellar nursery and offers a unique perspective on conditions during the era of cosmic noon, when stars were forming more rapidly. While it was previously believed that regions like NGC 346 were dust-free, scans of the galaxy have revealed massive clouds of dust, which actually accelerates star formation. According to Margaret Nair, the lead scientist studying NGC 346, this is the only major star cluster in its galaxy that is still actively generating stars. This discovery provides an exceptional opportunity to study cosmic noon conditions, and the abundance of dust in NGC 346 supports the idea that galaxies during this time were similarly dust-covered, providing us a unique view into the early universe. It is also speculated that NGC 346 could be creating planets, alongside stars, from swirling clouds of metallic dust. This suggests that Earth-like planets could have formed much earlier than previously thought. The new images from the James Webb Telescope are indeed astonishing. Even though the telescope has only been in orbit for a little over a year, it has already met all expectations, despite the immense complexity of stellar physics and chemistry involved. These stunning images contribute to a growing collection of breathtaking panoramas sent back to Earth by the telescope. Additionally, this instrument has allowed scientists to study the universe's infancy, revealing the existence of 6 massive galaxies that existed between 500 million and 700 million years after the Big Bang, dramatically changing our understanding of galaxy formation. The James Webb Telescope uses infrared light, a wavelength invisible to the human eye, enabling it to capture faint light from ancient stars in distant galaxies. This capability allows the telescope to look back in time, up to 13.5 billion years, challenging our preconceived ideas about the universe's early formation. The data gathered by scientists suggests that galaxies formed much larger than expected, challenging the current model of galaxy formation, which assumes that galaxies begin as small clouds of stars and dust that grow over time. While it is possible that the galaxies observed by the James Webb Telescope are slightly more recent, it is essential to remain open-minded about these observations, as this is our first glimpse at such distant objects. Although the data suggests that these are likely galaxies, there is also a possibility that some of them could be massive black holes. Regardless of the exact nature of these objects, the discovery of significantly more mass than expected is transforming our understanding of the universe. Even with a smaller sample size, there are various reasons why scientists may have miscalculated in their estimates, such as the presence of more efficient star formation methods than previously thought. This could have led the James Webb Telescope to mistakenly interpret the stars in these galaxies as older than they really are. If you found this video insightful, don't forget to hit the like button and subscribe for more updates.